Okay, so this video is about solving radical equations. And radical equations appear in science quite a bit. Basically, if you were to see a square, anything squared or anything cubed, anything to the fourth power, or conversely, if you see anything as a square root, a cube root, or an nth root, then you want to be able to do and undo that. Like you want to be able to go back and forth between them. All right. So, for example, if I have something, if I have x squared, all right, if I want to get x by itself, then I need to take the square root because a square root undoes a squaring, okay? Um, just like, let's say, for example, if we had like the square root of 9 squared, well, that's 9, right? Because 81, this would be 81. Take the square root of 81, and it's 9. All right, so that equals 9. So we want to be able to undo a squaring. And if you just, look through a physics book, you can see all kinds of formulas that involve squares, all right, and cubes, et cetera, et cetera. Calculating volumes and surface areas and stuff like that. If you want to go backwards, you want to be able to take the square root or cube root, whatever it is. So we want to be able to solve these equations, all right? So let's look at our first example. There's going to be 8 examples. I'm probably going to split up 4 in this video and 4 in the next. Our first example will involve just something pretty cut and dry here. Let's say that I have a value, it equals negative 28, and it equals negative 7 times the square root of, say, n. Okay. Now, I can't actually square anything and undo that square root of n because the negative 7 is being multiplied um, as a result. And so what has to happen is I have to actually, sorry, I got something in my eye. I actually have to do the order of operations backwards when I'm solving for a value. So squaring something or taking the square root of something is actually something that's in parentheses. And so that would be the P in PEMDAS. That would be the very last thing that we do. And so I actually have to divide by 7 here, a negative 7 on both sides, so that I actually get 4. Okay? So then, to undo this, now you can probably do it in your head, what n has to be in order for this to work, or you could kind of do it like the safe way and just do it mechanically. And what you want to do is you actually want to undo the square root by squaring it. But just make sure that you do it to the other side. All right, and then that way you're guaranteed that n is by itself. Okay. All right, so n is 16. All right, so example 2. Okay, as long as you follow the rules of PEMDAS going backwards when you solve for things, then you're going to be fine. Now, let's say, though, that it's not a square root. Let's say that I have a cube root, and I got 2x minus 4. All right, so I've got the cube root of 2x minus 4 equals 6. Okay, now in this example, I actually have the cube root all by itself on one side. So I actually can start the cubing. I can undo the cube root with a cube because it is isolated on one side. Up in this example, the radical n was not isolated. This negative 7 was attached to it by multiplication. So I had to undo it by division. So the inverse operation here of a cube root would be to raise it to the third power. That undoes it. And so I just have to make sure that I do it to this side as well. Now notice that I am putting 6 in parentheses. That's important because maybe there was other things. Maybe it was 6 minus x on the other side. And then I would have had to cube 6 minus x. All right. So that effectively undoes it. So that's great. It's actually pretty simple because it looks complex when you see a radical, but actually it's not. You can just undo the situation with a cube. Now, 6 to the third power is actually 216. And so I'm going to add 4 to both sides. So I get 220. And then I will divide by 2 on both sides, and I get 110. Okay? So, again, cube root. To undo a cube root, you just cube it. Make sure you do it to both sides. All right. Oh, so I got something in my eye, it seems. Example 3. Now, what if I have a little formula here? I have P equals R radical x minus 4. Okay. Now, this could have been a scientific formula. I don't know, some electrical formula for something. Who knows? But I actually have to solve for x now. Let's say that I have to solve for x. Okay, now x is inside the square root, so I'm going to have to actually get rid of the r first, just like I did over here. I got rid of that -7. I need to get rid of this guy here. So he's not a number. Well, he is a number. He's a value. We just don't know what it is. And so we're going to actually have to symbolically take care of him. We know that we're going to have to divide by r, okay, so that this would cancel out. So now I have a p divided by r equals the square root of x minus 4. Now that I have the radical sign isolated on either side, this just happens to be the right-hand side, I can actually square it. So once I square it, I have to square the other side. Now notice, now over here, I've been consistently putting in parentheses, the whole side in parentheses. I need to put it over both p and r. All right, so they are both being squared at this point. So now I have, I could write this a couple ways. I'm going to leave it like this for now. Okay. All right. So I have essentially undone the square root through the square, and these guys are now going to be squared. Okay, now I could have left it like that. That wouldn't have been an issue, but I might as well just distribute. You can distribute when you are, raising in fraction to a particular power. That's good. All right, so now I just have to get x by itself by adding 4. So if I were to add 4, I would just put plus 4. All right, and there's nothing else to do. The plus 4 will not go up here because that would mean that the 4 has to be divided by r squared. So you're just left with this kind of strange little formula, but this and this are basically, that's when p was by itself, and this is when x is by itself. We could have done it again where r is by itself. All right, so this is a very important skill for us to kind of switch our variables around because, when you look at a scientific formula, in a reference sheet, you might have the formula might be given with one of the variables solved for, and what if you need the other part of the equation? And so you have to be able to move things around in order to solve for particular variables. All right, it's a pretty good life skill. All right, this will be the last one for this video. Let's say we have this arbitrary video. Now your homework is going to look, it's going to have a problem just like this. I singled this out because it looks fancy and it could be intimidating to some people. So who knows what T is? T could have been, some scientists found that it was temperature, the temperature of the temperature of I'm thinking of a sphere, some kind of sphere, because it's got pi, it's got r. So the temperature of a sphere of iron at a particular level in the earth. It doesn't matter. I'm going to solve for r. But let's say this is temperature and that's radius, okay? And whatever the scientists figured out this formula, we actually want to know what is the radius if I have a particular temperature, okay? So I want r by itself. So I'm going to follow the inverse operations here. Right now, I need the r by itself, so he's got some tag-alongs here. Now he's buried inside the square root, so I'm going to have to wait. He's the last thing I need to take care of, or one of the last things. And you can see that this whole big fraction first is divided by 5. So if I want to undo the division of 5, I would multiply by 5 to both sides. So now I get 5t. Okay, now I'm being multiplied by pi to that radical. So I will divide by pi both sides. Now remember, 5t, I don't know what t is, so there's nothing I can do. I can absolutely leave this as a fraction, and there's nothing to solve for other than r. All right, that's the only thing I'm after here. All right, so now I have radical 6r. So since the radical is now isolated, I can now square this. All right, square everything on the left, square everything on the right, and I'm left with, let's see, that's going to be 25t squared over pi squared equals 6r. r. All right, so I squared everything. I squared the 5, squared the t, squared the pi. And there they are, all set. Last thing is to divide by 6. And so since this already has a fraction, okay, can do that. And so now r, and I'm going to switch sides. I like to put the isolated variable on the left. I have 25t squared over 6 pi squared. And that's it. There's nowhere else to go. I don't know what t is. But if I did have t, which is what's kind of assumed here in the real world, I would plug in a value for t for that temperature, and then I would actually get the radius. All right. So we'll stop there. We'll do 4 more examples, and that should cover everything that you need to do 14 problems in Excel math.